Hello, this is line 5, looking at polyprotic acids, acids that donate more than one proton. Before 2013, this used to be a very difficult question. You would have to calculate the exact pH and the exact species in the reaction. So we're only going to do the latter. We don't have to worry about trying to calculate the exact pH. That will be ignored. So this is still going to be a acid base. What's it called? This is going to be a ice table in the end, and let's go see how this is going to work. Okay, so right now we have a polyprotic acid. You know it's going to be more than one proton if there is something like two H's in front of the substance. So you can know that it's going to have more than one if the H's are like this one, where it's H3. This means that this substance, phosphoric acid, can donate up to 3 protons. Now, of course, every time it donates a proton, becomes less, it becomes more negative. So H3PO4 is a neutral compound, a neutral substance. As soon as it donates the first proton, it's going to have now a charge of -1. And when it donates the second proton, it's going to keep building up those charges. And so here we got H2PO4 -1 plus the H plus, which of course is in the water, H3O plus. And then if it does it again, right, it's going to keep getting more and more negative until you get -3 in this case. All right, so what's going to happen is the Ka value is going to become smaller and smaller. So when you look, the first Ka is going to be whatever, in this case 7.5 times 10⁻³ and then the two other equilibrium constants are so much smaller. And of course, hopefully you know where this is going. Once you have the first acid proton being donated, that first Ka is going to dominate, that first reaction. It's so going to dominate that there's going to be very little H plus ions being donated from the other two reactions, and so we can completely ignore it. There's also the fact that once H plus ions exist in solution because of the first reaction, let's focus on the second reaction. Here, in this case, the second reaction has H2PO4 breaking apart, okay, to form HPO4. This is -1, this is now -2, plus H3O plus. But there's already, in our initial conditions, before we even added any H2PO4, there's already this H plus ions in the water. And from Le Chatelier's principle from chapter 13, right away, because there's something in here that's not zero, it's going to push the reaction to the left. This reaction was barely going to the right in the first place, and now because of the first reaction giving us more H plus ions, the second reaction, which was very little anyway, since K1 is much, much, much bigger than Ka2, that barely is going to go to the right. And now with the H3O plus, which is pushing it to the left, the reaction that goes to the right is very small. So one more time, this was barely going to happen to the right anyway. The fact that there's already H3O plus ions in solution before any of the H2PO4 starts to dissociate means that it's going to push the reaction to the left, and we can basically ignore any H3O plus contributions from any other substance. Now, of course, if we're focusing on the actual anion, like HPO4 to negative, to minus, well, the only contribution that forms that is from this guy right here, so we would still have to now do an ice table. The only difference is now we have to start with whatever is produced here. So when you look at the homework questions, 105 and 106 is just basically telling you how to think about what's going to happen with more than one donation of the protons. And of course, when you look at what I wrote over here, this is all it's asking for. Okay, any other questions? So it used to be a question like 109, where they're asking not just for the pH, which you can ignore any other contributions from the H plus except for the H2S. But now in this question, they were asking about what's the concentration of S. So you would have to go through the whole thing, ice tables after the first, well, even every reaction, you'd have to go through each ice table. You would have to do H2S to HS and then HS to S, and basically look at all the different steps, find out the concentrations of the intermediates, such as HS. Anyway, you don't have to do that anymore. So that's why for line 5, it's just questions 105 and 106. Okay, so hopefully that helps. Thank you.